Hello everyone, this is Akshara and welcome back to my YouTube channel. So today I am back with another interesting circuit related project, that is controlling the intensity of light using LDR. So first let's see what exactly is an LDR. So the full form of LDR is light dependent resistor. That means like based upon the resistance of LDR, the intensity of light changes. So today we are going to make a circuit for that, and we're also going to code it and see how it executes. So as I've been mentioning in my previous videos that we'll be making all these circuits in a Tinkercad software, right? So first search for Tinkercad in Google, and then here go to the circuits part here. So then you'll get a setup like this, and now click on create new circuit. So click on create new circuit, and now we are going to first make a circuit for this, and then later we are going to code it using block code. And after we code it using the block code, it automatically gets converted into a C++ code. So let's see that also. So first, let's see what components we are going to use for this circuit today. So first, we are going to use an Arduino Uno, and then we are going to use an LED resistor. And the main thing for today's project is a photoresistor. Photoresistor is nothing but LDR. LDR is also called as a photoresistor. So let's see how we can do this. So first, we're going to choose an Arduino Uno. So this is the Arduino Uno. And then we are going to choose an LED. So after LED, we are going to choose the photoresistor. So after the photoresistor, we are going to take a normal resistor. So now let's make the connections. So this is the cathode of LED and this is the anode of LED. Always remember the cathode should be connected to the ground. So here in Arduino, you have various pins. Here, see here G and D. G and D means ground. So first I'm connecting the cathode pin to the ground. Then I'm connecting the anode pin to pin number 2. Here, this is pin number 2. So I've connected the anode to pin number 2. Then coming to the photoresistor, this is terminal 1 and this is terminal 2. So I'm going to connect the terminal 1 of the photoresistor to the ground. So let's see how we can connect it. So here we have the ground. So I'm connected to the ground. Then the terminal 2 of the photoresistor should be connected here to the resistor. The terminal 2 of photoresistor should be connected to the terminal 2 of the resistor. Okay, and then that wire should again be connected to the A0 pin. So the same wire here, it should be connected to the A0 pin. So this is the A0 pin and we've connected it here. Now the terminal 1 of the resistor should be connected to 3V3 pin. 3V3 pin is nothing but a 3.3 volts pin. So 3V3 pin is nothing but a 3.3 volts pin. So here we have the 3.3 volts. So I've connected it here. So this is the circuit that we have made. Now we are going to see the coding part. So now let's see how we can code this one. So click on the code button here, and already you'll be having an inbuilt code, but we have to remove it because we have to make a new code here. So the first step is you have to create a variable. So here you have this variable option, click on the variable and create variable. So you have to give a variable name. For example, I'm giving the name as LDR. Okay, so here the variable is created. So the first step is you have to set LDR. Here, set LDR. Set LDR to, here one option is there. There you have to select as read analog pin A0. So set LDR to read analog pin A0 because we have connected to A0, and from that A0 we'll be getting the values. So what value is stored in the A0 pin? So the LDR value will be set to that value. That's why we've selected as set LDR to read analog pin A0. And then now print to serial monitor with new line. So here another term we are getting, that is serial monitor. So here at the bottom of the screen we have serial monitor. Serial monitor means we will be getting the values, the output values. So when we run this code, we'll see how we can find those values. So the print serial monitor. So what should be printed in the serial monitor? The LDR value should be printed. So print serial monitor LDR with new line. So in the new line, it will be printed. Each value of LDR will be printed in the new line. After that, we are going to take an if else block here. If then else. Okay, and then we are going to choose this. We are going to keep a condition here. If the condition. So if LDR is greater than or equal to 68. Like let's take some random value. I'm choosing as 68. If LDR value is greater than or equal to 68, then set pin 2 to high. Why 2 to high? Because the LED is connected to pin number 2. High means turn on. So if this condition is true, then the pin number 2, that is LDR value based upon the LDR value. So if it is greater than or equal to 68, then the LED will turn on here. Else set pin 2 to low. Otherwise, this will be turned off. The LED will turn off. So this is the block code that we've written. So let's see how it will work. Yeah, so let's start the simulation. Okay. So this is serial monitor. So first you're getting the value here 671. So now I'm going to change the value of the LDR, and now let's see how the value will change here. So first let us like adjust this one. Okay, and now we'll start the simulation. See, first here it is showing as 671. Just a second, we'll adjust this first. See, for example, let's adjust it here. And now let's run it. Yeah, so first we are getting a 671. So now I'm adjusting this LDR, like the brightness of this. See, the values are changing, 263, 292, 306, 334. So if you keep on moving the slider, then the values will be changed. You can observe that in the serial monitor. So that's how you can control the intensity of light using the LDR. And LDR means light dependent resistor. So yeah, so this is the project of controlling the intensity of light using LDR. So all of you can try it. It will be really very interesting to make such circuit projects. And if you find this video useful, do like, share, comment, and subscribe to my channel. Thank you.